Alright, let's go ahead and see what is multi-layer perceptron. In previous lesson, we had seen what is the neuron. So these neurons are, you can say that it is just a single unit, and in deep learning term, it is referred as a single unit of the neuron. When you have a multiple neurons together, then you make a multi-layer perceptron. So overall how it is built, let me just redefine this definition one more time. So this particular thing is known as neuron. Other than that, it is also known as linear threshold unit. Why it is known as a linear threshold unit? Because when you apply their activation function, then this input get multiplied by a weight, and then finally these are getting summed together, and in real sense there is just a single input which is coming to the neuron, and then activation function is applied there. So based on a particular threshold, output is decided whether output can be 0 or output can be 1. That is why it is known as here a linear threshold unit, and it is also known as a single layer or a single neuron there. So this LTO is a linear function of its input followed by a step function. That means this activation function is actually the step function. So when you're multiplied by this weight, this value, input and multiplied by weight, reaches a particular threshold, then it compared with the step function, and when it reaches above a threshold, then output is 1, otherwise it is 0. So this step function which is written there, that is also known as the activation function. We will be seeing a detailed lecture on the activation function in coming lectures. And when you have something like this activation function, like a step function, then your linear threshold unit becomes a non-linear classifier, which means it can classify data that is not linearly separable. In our classical machine learning algorithm, we have seen how you can apply classical ML like SVM, random forest, decision tree, all these algorithms when your data is linearly separable. When data is not linearly separable, then it really becomes difficult for those classical machine learning algorithms. So when it becomes difficult for classical ML, that's where you apply a deep learning models. If you see the type of the deep neural network, there are two major type of the deep neural network, a shallow deep neural network and the deep neural network. In a shallow neural network, you have just a single hidden layer. There is an input layer, there is a hidden layer, and then there is the output layer. But in deep neural network, we have a multiple hidden layer. Now let me explain you what are these layers. So whatever these circles you see there, these are a single neuron, or you can say that it is single linear threshold unit or LTO. When you combine all these in a group, then it becomes a layer of neuron. When you make here a multiple layer of these neurons, then it becomes there a multi-layer perceptron. So these things you can say that there is a perceptron, and when it becomes here a multiple layers, then it becomes there a multi-layer perceptron. And when there are many hidden layers, at least 2 hidden layer or more than 2 hidden layer, then it becomes a deep neural network. Now in this case, you see all of these layers, hidden layers, are connected with all these backward neurons and also with the forward neurons. The same thing you also see here. These neurons are connected with all the previous neurons and also all the forward neurons. And this signal, this line which you see there, this says that there is connection between this neuron to this neuron. That means a signal is being passed from this neuron to this neuron and this neuron to all other neuron. And similarly, this neuron is also receiving signal from this input and all other input. So this type of the network, whether you see here or here, when a neuron is connected with all the neurons which is before this layer and after this layer, then this type of neural network is known as a fully connected neural network. Or you can say that these type of the layers also known as a dense layer. So the dense layer is something which is fully connected or densely connected. So let me explain you once again in the term of here how this happens in biological neuron. A signal comes here and then signal moves from here through the axon, and then there is the axon terminals, and then this axon terminal is connected with the another neuron, that's the human nervous system, and then whatever the signal is here, then that signal is passed to the another neuron, and in meantime this neuron either amplify or reduce the signal. So this axon carries the impulses from one cell to another cell or one neuron to another neuron. So the same thing you can visualize. These connected lines are kind of the axon which is actually carrying these information from one neuron to another neuron. So whatever the input is coming from here, whatever input is coming to these input layers, it is becoming the output here, and the output of this neuron is becoming here input of the forward layer. And the same thing happens when you have a deep neural network. Output of first layer becomes the input of these hidden layer 1, and the output of the hidden layer 1 becomes the input of the hidden layer 2, and so on. And at the last stage you get the output layer. So these number of neurons are decided how many output you want. If you are doing a binary classification, then obviously at the one single neuron you can get the value at 0 or 1. So there is just one neuron or just one cell there. But if you have 4 classes, then you can have something like this, a 4 neuron, and out of those 4 classes, these neuron will be saying that which class is selected there, which class is the actual output, and the probability of that class will be high there. Alright, perfect. So this is all about in this lesson. Thanks a lot for watching this. I'll see you in next one.